Hi, everybody. Good morning. So today is October 4th because we are behind schedule. So let's move homework 4 to do next Wednesday. Okay? And we need to catch up. So by the way, this Friday, from 11:30 to 12:30 in Snyder 154. We have the WISE Club interest meeting. So WISE, okay. Women in Computer Science and Engineering. So, all right. Everybody is welcome. Are you in any organization? So I think it's good to be in a certain organization and then maybe in the future become a leader, because then you can put this on your resume. You have some leadership experience and you can get along with other people. You have more things to talk about on the resume.
So is it like a meeting?
Yeah, interest meeting, and then we teach them. So just come, and if you want to be a member, write down your name and emails. And not just women, men are welcome. Hey, NASB has not only flag, right?
Yeah.
Everybody's welcome, right?
Everybody's welcome.
Yeah. Are you a NASB?
Yeah.
Yes. Okay, right. So let's see.
And it's today?
Friday.
Friday.
So Friday. Yes. This Friday. And Dr. Anna Lego and Dr. Shada are the advisor of this. So I'm like the third advisor of this. Okay. Yes. And let's see. So let's continue. Session 4.2. So last time we talked about derivative, right? Rate of change, and we introduced the displacement function, the position function, right? The average velocity is change of the displacement over change of time. This is like the slope of the secant line. And then we have the instantaneous velocity, which is like the sum of the tangent lines, the velocity at that moment. It's the derivative of the displacement function. And then we plug in the time, t equals to a. Is that okay, everybody? And speed is the magnitude of the velocity. And acceleration is the derivative of the velocity, right? And let's look at examples. So suppose a stone is thrown vertical upward with an initial velocity of 64 feet per second from a bridge 96 feet above a river. Okay, so you draw some picture. We have a bridge and we have some river. You stand right here and you throw a stone upward at 64 feet per second. And then the bridge is 96 feet above a river. So far, so good, everybody? So this is the picture. And by Newton's law of motion, the position of the stone measures as the height above the ground. After t seconds is s of t, so s stands for like displacement, is negative 16t squared plus 64t plus 96. You, you know we have the gravitational force, right? So the acceleration due to gravity, the g is, if you said the upward direction is the positive direction, then the gravitational force is negative, right? Because it's the attraction from the earth. So it's negative. If we're in the feet system, then it's 32.2 feet per second squared. But usually people want to calculate, make it easy to calculate, they just use 32 instead of 32.2. Okay? And if we use meter system, then it's negative 9.8 meter per second squared. Is that okay, everybody? Actually, from the unit, you can tell what the thing is. Displacement. The unit is like meters or feet, right, everybody? But velocity, right? Velocity, the unit is meter per second or feet per second. Because velocity is like displacement over time. That's like meter per second, right, everybody? And acceleration. Oh, sorry. Why did I put that? I mean, v of t is the derivative of s of t. And a of t is the derivative of v of t is the second derivative of s, right? Therefore, the unit is meter per second square or feet per second square. Okay, so it could be like feet per minute or miles per hour square in the case of acceleration. Okay, so the unit could be miles, the time could be minutes, hours, per year. Okay. All right. So part A, find the velocity and acceleration function. So we have displacement. Velocity is the derivative of the displacement. Let's take the derivative. What's the derivative of negative 16t squared? Explain. Yes, negative 32t. Right? The power dropped down by 1. So t squared derivative is 2 times t. Is everybody okay with that? And then the linear term becomes 64, a constant. Because the degree 1 term, your degree drops down by 1, and then you get the constant. So this is the constant coefficient. And then the derivative of a constant is 0. Then we don't need to write down the 0. So this is the velocity. Is that okay, everybody? And then acceleration is the second derivative of the displacement. It's also the derivative of velocity. So you have this is the velocity, and you take the derivative. What happens? Will? Yes. Oh, see? It becomes negative 32, which match this, right? Yeah. So keep in mind from this. Have you seen these numbers before? 9.8. Okay, good. Okay, good. So this makes sense. But this is only true when we are on the Earth. If you're on the moon or other planets, the G will be different. Okay, and part B. Hi, Dante. Welcome back. So this is your exam. Make sure you watch the recording for the things you miss. Okay? Yeah. What is the highest point above the river reached by the stone? What is special at the highest point? So, at the highest point, what is special about it? See, your velocity is going up, but then at this moment is 0. Yes, and then your velocity is going down. Okay, everybody? Yeah, so at the highest point, so at the highest point, the velocity is 0. Okay, let's find the t. Velocity is negative 32t plus 64. We set this equals to 0. Is that okay, everybody? The velocity is 0, and we want to find the time. Okay. Let's see. Let's find Oh. Oh, okay. So sorry. The Friday was the exam. And okay. So let me just cross this out and switch to now you sign in for the lesson. Okay. Thank you. So we solve for t. How do we solve for t, Dylan? Mm-hmm. Okay, minus 32t equals minus 64, and then yes. So t equals 2 seconds. Right, everybody? So for the explication problems, for my class, it's okay that you include a unit or you don't include a unit. For my class, it's okay. But in your chemistry class or physics class, if your instructor asks you to write down the unit, you must write down the unit. Okay, don't tell them like, hey, Suki said it's okay. No, it's only okay in my class. Okay, everybody? Mm-hmm. Yes. So t equals to 2 seconds. Okay. And see part B, what is the highest point? It's not asking for the time, it's asking the highest point. The highest point is like the position function. Right, everybody? So we put the 2 in where? We put the 2 in velocity, acceleration, or displacement? Huh? Displacement, yes. So S of 2 is, so we plug in here. Negative 16, 2 squared plus 64 times 2 plus 96. Every time when you see t, replace t by 2. Is that okay, everybody? Mm-hmm. All right, Paige. What is 2 squared? 4. What's 4 times 16? Yeah, negative 64. Oh, you see, we minus 64, and then we add 2 copy of 64, so we get what? 64 plus 96 is 160. Yes. And 160, what's the unit? Feet. Yes. Just feet, right, everybody? So this is the highest point above the river, 160 feet. Okay, and then part C. With what velocity will the stone strike the river? The strike the river, which I'm here. What is special about here? What is zero? The velocity is zero, or the height? The height is zero. The displacement is zero. Right, everybody? The highest point, velocity is zero. Right? And then when you strike the river, the displacement is zero. Okay. So we want to find the t such that the displacement equal to 0. Okay, displacement, negative 16t squared plus 64t plus 96. Set this equal to 0. Oh, I ran out of space. Let me see. Can I do that and shrink it? Okay. This is the good thing about Word. I can shrink it. Then I can have more space. Okay, so we want to solve for t. All right. So I don't like the leading coefficient to be negative. So I will go sides multiply by -1. Is that okay, everybody? Mm-hmm. Do you see a common factor? 16. Oh, 16. So both sides divided by 16. Then we get t squared. What is 64 divided by 64? And we change the sign, right? What's 96 divided by 16? 6. Thank you. See? This looks much nicer. So simplify it. Okay, everybody? Are you able to factor? 6. It could be 1 and 6. Or it could be 2 and 3. None of those work. Then use quadratic formula. Okay? So quadratic formula, we have t equals what? The t is time. The t is the time. And then the s is the displacement. The v is the velocity. And a is the acceleration. So velocity is the derivative of the displacement. And yes, but you have to find the time first. After you find the time, when you strike the lever, very good. Then you plug that time back to your velocity, and then you can find the velocity at that time. So this is a two-step process. Okay, everybody? Like part B. Part B also is a two-step process. You find the highest point, but you need to find the time first. So what happens at the highest point? Your velocity is 0. So you set the velocity is 0 to find the time. Then you plug the time into the displacement function to get the highest point. So part C is also the two-step process, but you set the displacement in 0, and then you solve for t, and then you plug that t into your velocity function to get the velocity at that time. Is that okay, everybody? Mm-hmm. Good. So what is the quadratic formula? Minus b, which is? Which is 4. And then? B squared is 16. And then? Yeah, very good. Over 2. 2a is 1, so we get 2. Oh, we get 4 plus or minus. Do you see here where the negative multiply become positive? And 4 times 6 is 24. 24 plus 16. 40. Yes. So square root of 40. Do you know square root of 40 is like 4 times 10? And square root of 4 is 2, right? So we have 2 square root of 10 over 2. So you can split them. 4 divided by 2 is 2. And then the 2 and 2 cancel. You get square root of 10. Is that okay, everybody? Yes? Aha! Because we're talking about real life problems. You see the negative? No. So we only pick the positive roots. By the way, you know 2 is smaller than square root of 10, right? Because 2 is square root of 4. And 4 is less than 2, so 2 is smaller than square root of 10. So that's why the negative sign will make the t negative. So we only pick the positive sign. Then we plug in, yes, we plug in. So continue here. V of 2 plus square root of 10 is, what's the V? Here. Right, everybody? This is the velocity function. We plug in t equals 2 plus square root of 10. So minus 32, t is 2 plus square root of 10. And then we add 64. Is that okay, everybody? All right. Yay! So distribute. What do you get? Mm-hmm. What happened? Yes. So we got, yes. And what's the unit? Feet per second. Yes. And the time, the unit is second. Okay. Right. So this is the velocity. And can you see it's negative? And it makes sense because it's right, the river is going down, the velocity is going down. So that's why it's negative. Questions?
So you find the velocity of the acceleration for the, you just find the derivatives.
Yes. You just find the derivative. Mm-hmm. Good. So watch the recording of last class and at the beginning of this class. Mm-hmm. Okay. Yes. Any questions? Oh, good. Okay. So example 2. Wow. Okay. Let's see. Example 2. This is the function. Okay, and this is the displacement function. We want to describe the position of a particle moving in the direction of the positive x-axis, where x is measured in feet and t is measured in minutes. See, it's not seconds, it's minutes. Question part A: find the velocity and acceleration function of the object. Okay, so displacement is s. And what is velocity? Joseph. Let's see. 15 over 6? Oh, okay. So this is the derivative of the displacement. You're using 5 over 6 times the derivative of t cubed is 3t squared, right? That's why you get 15 over 6. But actually, instead of multiply the 5 and the 3, you can actually cancel the 3 and 6. And what do you get? You get 5 over 2. Yes. Right, everybody? So write it out. If you can cancel the denominator, cancel it. So you get the lowest terms. Okay, yeah. Good. How about the next term? Yes. Next. Good. So our answer is 5 over 2 t squared minus 16t plus 9. Is that okay, everybody? This is the velocity. How about acceleration? Layla. So acceleration is, yes, second derivative. Yes. And t, right? And then, yeah, minus 16. So we get 5t minus 16. Is that okay, everybody? Oh, so this is part A. We find the velocity and acceleration function of the object. Okay, so part B. Find the velocity at t equals to 4 minutes. So we plug in v of 4. Is that okay, everybody? V of 4. So we plug in t equals to 4 is the velocity, right? So let's see, 5 over 2. Frank, what is 4 squared? Yes. And we continue. Minus 16 times t is 4 plus 9, right? Let's cancel. 2 and 16 cancel. What's left? 8. What's 5 times 8? 40. What is 16 times 4? 64. Yeah. Thank you. Right, everybody? And what's the unit? What's the time? Time, the unit of for the time is minute. Yes. Right. Okay. And it also asks, is the object moving to the right or moving to the left? Oh. So remember the positive direction is moving in the positive x-axis. So the positive x-axis is here. This is the positive direction. Yeah. So move to the left. Is that okay, everybody? Mm-hmm. All right. Next. Will. Acceleration at t equals to 4 minutes. What do you do? Acceleration. Yeah, plug in 4 for t. And what do you get? Hmm? Acceleration. Acceleration. Where is your acceleration? Here, right?
Okay, so you gotta plug in 4.
Mm-hmm.
So it'll be 5 times 4 minus 16.
Which is?
4.
Yes. Is that okay, everybody? 20 minus 16 is 4. What's the unit? Feet per second. Minute square. Okay. And is the object speeding up or slowing down? Okay. Oh, yes. Yes, very good. Remember last time I tell you for velocity, if you look at the directions, if it's positive, then move to the right. If it's negative, then move to the left. But for acceleration, you don't look at whether it's positive or negative. You look at whether it's in the same direction as the velocity. If they're in the same direction, then you are speeding up. If you're in the negative, opposite direction, then it's slowing down. Okay, everybody? So even though this is positive, it doesn't mean it's speeding up. It's actually the opposite direction as the velocity. So that's why it's slowing down. Okay, so A and V are opposite direction. So slowing down. Is that okay, everybody? Mm-hmm. All right, we finished 2 examples of the one dimension motion. Okay, let's continue. So we have more applications. The second application is the growth model. So let P equals f of t be the population of a species or consumer price index, where t represents times. Then the average growth rate is the change of the population over change of time. Okay? This is like the average velocity, right? And then the instantaneous growth rate is the derivative of the population function. This is like the instantaneous velocity. Okay? But we use different names. So if we have the growth function, then we say average rate of change. And this is instantaneous rate of change that becomes instantaneous growth rate. Okay, look at example 3. The number of worldwide internet users between 1995 and 2010 can be described using a function. So this is P of t equals this. But t measures the years after 1995. So that means 1995 corresponds to t equal to 0. Is that okay, everybody? So t is not 1995. And find the growth average growth rate of the internet user from 2000. See, 1995 is 0, then 2000 is t is 5, right? To 2005, which means t equals to 10. Okay, so average growth rate. So part A, the average growth rate is change of the population over change of the time. And our final point is 10. So P of 10 minus the initial point, T is 5. Is that okay, everybody? And the denominator, the final point is 10 minus the initial point is 5. Okay. Now we calculate what this is. So P of 10. Well, we look at the population function, right? We plug in T equals to 10. Oh, do you see? This is 3. Bless you. 3 times. Did I ask Dylan? Okay, Dylan. We plug in T is 10. What's 10 squared? 100. And then plus 70.8 times T is 10, right? Minus 45.8. So this is P of 10. Is that okay, everybody? And then we need to subtract. We plug in T is 5. So Dylan, what do we plug in? What do we write here? Mm-hmm. Mm-hmm. Yes. Over 10 minus 5 is 5. Yes. Okay, good. So you can multiply out. So 3 times 100 is 300, right, everybody? And then 70.8, when you multiply by 10, you shift the decimal dot here, 1 digit here. So it becomes 708. Is that okay, everybody? So plus 708 minus 45.8. And next, you gotta be careful because it's negative. The common mistake is students might forget to put the parentheses here. Okay, so now when you break the parentheses, you need to change the sign. What's 3 times 25? Page 75, yes. And then, see, we distribute, it becomes minus. What is 70.8 times 5? Thank you, 354. And next, you see, minus become plus 45.8. Right, everybody? And all over 5. Oh, do you see 45.8? We can cancel, right? Okay, Gabby, can you use your calculator, add these numbers, and subtract these numbers, and then divide it by 5? What do you get? What? 579 divided by 5. Thank you. And that is? Thank you. So 115.8. So far, so good, everybody? So this is the average growth rate. Change of P over change of time. We look at the initial point and the final point. All right. Part B. What was the instantaneous growth rate? Okay, instantaneous growth rate. We need to find the derivative, right? Find the derivative. Oh, Dante, what's the derivative? Mm-hmm. Yes. Good. And see, we want to find the instantaneous growth rates in 2006. 2006 corresponds to t equals what? 6? Look at this. Look at this. T is 0 in the year 1995. And 2006 corresponds to t equals 11. Right, everybody? So t is 11. So we plug in t is 11. So 6 times 11 plus 70.8. Joseph, what do you get? What's 6 times 11? What's 66 plus 70.8? Yeah, very good. Right, everybody? Mm-hmm. So this is the average growth rate, and this is the instantaneous growth rate. So instantaneous growth rate, we need to take the derivative and then plug in the time. Okay, part C. Assuming that the growth function can be extended beyond 2010, what is the predicted number of the internet user in 2015? Leila! So part C. What's the predicted predicted number of the internet user in 2015? Where do you plug it? Do you plug in the average growth rate, the instantaneous growth rate, or the population function? Yeah, the population function, right? We want to know the population of the internet users in 2015. So 2015 corresponds to, what's your T? 20, exactly, good. So T is 20. And we plug in the population function. So can you tell me what you get after you plug in? Thank you. Do you have a calculator? Could you put this in your calculator? Good. So 1200 plus, oh, you can type the whole thing. So in one line. Then what do you get? Thank you. Yes, very good. So then we finish this problem. So it's a similar idea. It's like average velocity, instantaneous velocity, so we just use different names. So instead of displacement, we have population, but instead of average velocity, we have average growth rates. And instead of instantaneous velocity, we have instantaneous growth rates. Okay, everybody? Similar. Okay, that's the second application. The third application, cost. Okay, in business and economics, the cost function C gives the cost to produce the first X items in a manufacturing process. The average cost to produce X items is the cost function C of X over X. Okay, everybody? And this is the average cost. You can also think of this is like a change of cost over change of X, same idea. But if you produce nothing, then you just assume it's 0. Okay? That's why C of X minus C of 0, and then over X minus 0. This is just 0. We have C of X over X. It's the same idea. Change of the, yeah. So this is the average cost. The marginal cost is the derivative. It's the approximate cost to produce one additional item after producing X items. Okay, everybody? So marginal cost and average cost. Okay, so suppose the cost for producing X items is given below. Okay, so what is the average cost? So we put a bar on the C. This is the average cost. By definition, is the cost function over X, right? Wait, all the terms divided by X, what do you get? Yeah, what do you get?
You want the final function?
Yes.
So it'd be minus 0.02 x plus 50 plus 100 over x.
Yeah, very good. Right, everybody? So you can put this whole thing over X, then simplify it, split them. Okay, everybody? Yes, simplify them. Good. This is the average cost and the marginal cost. What's the marginal cost? Well, what's the derivative? Yes. Right, everybody. That's it. Okay, good. Oh, that's part A. Okay, part B. Find the average and marginal cost when X is 900. So we plug in 900. Okay, the average cost when we plug in 900. Dylan, what do you write here? And then plus. Yes. Do you have a calculator? If you plug in, what do you get? By the way, do you know the 0.02 and then this 0? You can kind of cancel. Then you get 2 times 9, which is negative 2 times 9. Yeah, negative 18. So negative 18 plus 50 is 32. Oh, so this is 32 and 1 over 9. Yes. And 1 over 9 is actually 0.11111. So you can also use 32.1 and then the 1 repeated. Is that okay, everybody? And marginal cost. When we plug in X is 900. Page, what do you get? Oh, good. So we plug in the marginal cost function, right? And we multiply by 900 plus 50, and you said 14? Thank you. Yes. Very good. So this is example 4. So we did 3 types of application. The one-dimensional motion, okay, displacement velocity, and we did growth rate, population growth, and then we did the cost. Okay. And now let's look at example 5. We might not be able to finish both examples. Let's pick one. Okay. How about let's do example 5 and then example 6. You guys so I already posted the solution on the website. Can you follow the solution and figure it out? If you have questions, feel free to come to see me. Yeah, because we're behind schedule. We're not able to cover all the examples in the worksheets in class. Okay, so example 5, we have the position function is that. See, all the example we did, we just did the polynomial. This is something more interesting. We have rational function. Okay, so find the velocity function for the marble. So velocity is, if it does not tell you its average velocity, we just assume it asks you the instantaneous velocity. Is that okay, everybody? So velocity means instantaneous velocity. Okay. So part A, find the velocity. Instantaneous velocity is the derivative. And do you remember last time we talked about product rule and quotient rule, right? So product rule, we have uv prime is, remember two friends go to the restroom, they go one by one. So u prime v plus uv prime. Yes, everybody? And then the quotient rule is the numerator. It's very similar, but you change the sign in the middle to be negative. Okay, everybody? And denominator is the denominator square. Are you okay with this? Okay. And now, so we use the quotient rule. We use the top guy prime times bottom minus u is the top times bottom prime. Is that okay, everybody? All over the bottom square. So we do it slowly. Each step, just do one thing. This first step, we write out the quotient rule. Are you okay with the quotient rule? Mm-hmm. So now we continue. Let's see. Gabby, for the vector with the prime, we take the derivative. What's the derivative of 100t? 100. Yes. So this is 100. And what is the derivative of t plus 1? 1. Oh, yeah, this is easy. This is 1. And then all over t plus 1 squared. So far, so good, everybody? Here, because we're working with application problems, later on we need to plug in numbers. So it's better to simplify it. Let's simplify it. So distribute. If you distribute, what do you get? Joseph. Yes. And then minus 100t. Oh, what happened? Yeah, 100t cancel. We get 100 over t plus 1 squared. So far, so good, everybody? This is part A. Part B. At what time is the marble 80 meters from its starting point? Look at the unit. Meter. What's it? Distance, right? Meter per second. This is velocity. Meter per second square is acceleration. Yes. So we're looking for the t such that the distance, displacement is 80. Okay, everybody? So part B, we find the t such that the displacement, see, the displacement is this, equals 80. Right? How do we solve equation? Well, I would say both sides multiply by t plus 1. You get 100t equals 80 times t plus 1. Is that okay, everybody? Both sides multiply by t plus 1. Here t plus 1 is gone. Here 80 times t plus 1. And we want to distribute. Or maybe we can cancel it. We can cancel the 0. Do you agree, everybody? What's the common factor? 10 and 8. 2 divided by 2. What do you get? 5t is 4 times t plus 1. If we both sides divided by 2, right? And now we can distribute. So 5t is 4t plus what? 4. Yes? Everybody? What do? Move the 4t to the left. What's 5t minus 4t? Oh, t is 4 seconds. Okay, everybody? So t equals 4 seconds. By the way, there are so many different ways to solve equations. So you can divide it by 50 on both sides. And then you move the t to the left. It's okay. Okay? And I just like to try to avoid deal with fractions. That's why I do this. But there are so many different ways to solve equations. Sorry, let's finish part C, okay? At what time the velocity is 50? So C is you find the t such that the velocity, so 100 over t plus 1 square equals 50. Here I would do cross multiply. Okay, if you both sides is a single fraction, then you can do cross multiply. So you get 50 t plus 1 square is 100. Is that okay, everybody? Then you can, I can divide it by 50. Then I get t plus 1 square. What is 100 divided by 50? 2. Then because it's a complete square, you can take square root on both sides. But when you take square root, you get plus or minus square root of 2. Plus, let's see. Right, okay, so yeah, and we solve for t, so we need to subtract 1. Therefore, we get t equals plus or minus square root of 2 minus 1. And then here, you look at, we cannot pick t to be negative. So that's why we only pick the positive. So t is square root of 2 minus 1. Okay. Here, don't forget the plus or minus. You decide which number to pick at the end. Because you might happen that you might have t equals a plus or minus square root of 2 plus 5. In this case, you pick both of them because both of the roots are positive. Okay, everybody? So just in this case, the negative sign will make the roots negative, and we don't consider it. But it could happen both of them are positive, then you have to include both of them. Okay, so yes, we finished this problem. So next time, please print out 4.3 worksheets, and yeah, okay. Please watch please do the example 6 at home, and I have solution on the website. Have a nice day. Oh, by the way, Dongje, we postponed the homework for to be next Wednesday because we're behind schedule.